understood how planes really worked. I've been on a lot so far in my life and finally discovered that although designing a plane involves engineering work, physics also plays an important role when designing a passenger plane so that people have a smooth flight and thus the plane works accordingly. So without further ado, I wanted to further understand the physics content relevant in the domain of engineering design for planes, such that when designing an aircraft, an engineer must take into account the net forces involved in taking off, cruising, and landing speeds and the extent of any alterations that may affect the passenger's flight. But specifically, my investigation examines factors that affect lift force, or what is usually determined as normal force when not in the air, and how engineers can design planes ensuring that they'll be able to lift off the ground properly using the lift equation of an aircraft. But first, let me explain the basic physics behind a plane in motion in order to lift off the ground. Dealing with airfoil force called lift force, the force pushing up on the plane opposite of gravity, which makes the plane fly. So there's actually a pressure difference between the top and bottom part of the airfoil. The higher the angle the wing creates, the larger lift force, where there is more pressure on the bottom of the wing than there is on top of the wing. So furthermore, airspeed can also increase the air force on the wing, allowing for more lift force. And after researching the engineering and physics of an aircraft's wing, there are 3 techniques to increase airfoil oil of the wing, which is the lift force: a high speed, an increased angle of attack for a larger drag force, and the use of the flap and slat. So in order for a plane to take off, lift force must be greater than gravitational force. So this means that there must be an increase in initial speed and increasing the flaps and slats. Elevators also help with lift force to increase angle of attack of the airfoil on the lift force. After the plane successfully lifts off, the plane moves upward to reach level flight, where thrust must be more than drag force of the plane to increase the plane's speed, which means a higher lift force, and the purpose of this is to get the plane at its level flight. Now, in order to examine the impact of the lift equation, it is important to examine the system schema of drag forces when the plane leaves the ground. So, a system schema for the plane, right after liftoff, involves the plane and the earth because these are the only 2 subjects in our system. Now, for the force diagram, this consists of drag forces, thrust, gravitational, and of course lift, which must be larger than gravity for it to take off. Comparing the Boeing 777 to the Boeing 747, these planes look very similar except maybe for the amount of engines in the flap here and there. But in terms of their statistics of their design, it turns out that each plane type calculates out at a different lift force. The lift force calculation being coefficient of the lift times density of the air with respect to the height of the plane times velocity squared times wing area all over 2. So comparing the lift forces between the 2 right at takeoff, the Boeing 747 is 2,409,073.45 newtons, while the Boeing 777 is 7,556,780.63 newtons. And looking at the equation and using the engineering statistics to create the models of the planes, it is clear that these wings must be capable of handling large forces since this number in newtons is very large. Furthermore, if we were to convert these to pounds, Boeing 747 would be 541,581.3 pounds of force, and Boeing 777 would be 1,698,831.9 pounds of force, which might be due to the large coefficient used to do calculation when finding the coefficient. Regardless, both show very large lift forces. But how is it that at these angles for the wings, the plane is still able to lift again? Well, it has to do with the high speed, an increase in angle of attack, and the use of the flap and slat. Given this, there's not a perfect wing type for a plane per se unless it is out of the ordinary, but rather it takes the shape of a raindrop if it were to be viewed as a cross-section of the wing. This shape allows for ideal pressures, top and bottom, as well as lift force to propel the plane up, overpowering gravity. And so in conclusion, there are a lot of variables and interactions for an aircraft during flight and at takeoff, so that each flight will run smoothly. But one of the most important variables for a plane to lift off is its lift force and how the plane wing interacts with its takeoff.